see this, what we can say, these are the valence state, which are
મેથ્સના પેપર ઓછા છે તો ફોન કરવો પડશે કાં તો ઝેરોક્ષ કરી લે.
Valence state means the electrons which are present in the outermost orbital in the state which are responsible for the bond formation. So definitely the electrons that will not be present in the ground state, they will be present in the excited state. For example, let us talk about the carbon atom, atomic number 6, helium core. Now these are said to be core state. They are very close to the nucleus and they will not at all take part for the any kind of bond formation. The other state is known as valence state, that is 1s2, 2s2, 2p2. This is said to be ground state. And now the excited state, helium core again, 2s1, 2p3. This is said to be excited state. And these are said to be valence state that are ready, that are capable for the formation of the bond formation, and the transfer of the electrons also may occur from central atom to any other atom, or from any particular group to the central group. So now let us try to understand. This is about the valence state. Ionization. Let us take this particular word. Ionization means what? What is the meaning of the ionization? Dhruvi, you want to say something? Or let us combine the word ionization potential. Hello. Ionization, that is either removal of the electron or addition of the electron. So either carbon can be converted into carbon plus, this is said to be present in the ionic state, or say carbon minus, this is also said to be ionic. So the potential that we have to apply, particularly in this part, it is the removal of the electron. The potential, the amount of energy that we need to employ to convert the element into the ionic state from the valence state, the electrons that can be removed from the valence state, and it will be converted into ionic compound, ionic element. The amount of energy that we need to provide for this particular thing is said to be valence state ionization potential. Say for example, carbon, if I write helium core 2s1, 2px1, 2py1, 2pz1. This is said to be present in the excited state. This is the valence state, which is ready for any kind of the chemical bond formation, any kind of chemical reaction. Now, if I want to remove one electron, so 2s1, 2px1, 2py1, 2pz0. Now say, try to understand the difference between these one. This we can write with 2s1 2p3. Now this will be 2s1 2p2. We have removed one electron from the valence state. It has been converted into ionic part. How much amount of energy, how much amount of potential we need to provide for it? This is said to be VSIP. How much amount of energy should we provide if we want to remove one electron from the 2pz orbital? The amount will be different if we want to remove one electron from 2s orbital, 2s0, 2px1, 2py1, 2pz1. Now this is 2s0, 2p3. This was 2s1, 2p2. Now, this is said to be how much amount of the potential do we have to apply for the removal of one electron from the valence state to convert it into ionic compound, ionic element is said to be VSIP. The amount of energy that we need to apply to remove one electron from the 2s orbital will be greater than the electron that needs to be removed from the 2p orbital. Why? Because 2s orbitals are closer to the, say, n is equal to 1, n is equal to 2, 2s, it will be closer to the nucleus, 2p, they are away from the nucleus. So to remove an electron from the 2s orbital which is closer to the nucleus, a forces of attraction will be there between the electron and nucleus. એક ઇલેક્ટ્રોન અહીંયા છે અને બીજો ઇલેક્ટ્રોન અહીંયા છે. So these will be having more forces of attraction closer to the nucleus. So આને remove કરવા માટે વધારે energy આપવી પડશે. If you want to remove one electron from the 2p orbital, it will be requiring less amount of energy because it is away from the nucleus. So forces of attraction intensity will be less. So these can be removed very easily. This can be removed by providing more amount of the electron that we need to remove, which are present in the valence state, to convert it into ionic one is said to be VSIP. The potential that we need to apply, the energy that we need to apply to remove an electron from the valence state to convert it into ionic one is said to be VSIP. Valence state ionization potential. From carbon atom, it is present in the excited state to convert it into C plus. This potential is known as VSIP. Generally, we write delta G is equal to minus something, right? We write in this manner. So this is VSIP, and let us compare some of the energy value. So carbon excited state plus potential to convert it into C plus. This is said to be VSIP. So either carbon, helium core, 2s1, 2px1, 2py1, 2pz1, 2 plus energy, Either it will be converted into helium core, 2s1, 2px1, 2py1, 2pz0. This is the difference. Or plus energy to convert it into helium core, 2s0, 2px1, 2py1, 2pz1. So this is the difference. The amount of the energy with this one will be comparatively more compared to this one, because 2p orbitals are away from the nucleus. So smaller amount of energy has to be provided for its removal. કેટલીક એનર્જી આપણે જોઈ લઈએ. હાઇડ્રોજન, કાર્બન, નાઇટ્રોજન, સિલિકોન. 1s, 2s, 3. minus 13.6. Do not consider this value, કારણ કે આપણે જે મેં હમણાં તમને કહ્યું કે we are writing generally with the delta G is equal to negative. Okay, અહીંયા 2s અને 2p ની વાત નથી. કાર્બનમાં 1s, this is helium core, so no question of writing 1s electrons removal. 2s ના electron ને it is minus 21.4. 2p na electron ne minus 11.4. Do not consider this minus value. જો 2p na electron ne remove કરવા માટે 11.4 electron volt energy આપવી પડે છે, જ્યારે 2s ના electron ને વધારે energy આપવી પડે છે. It is 21.4. Do not consider the negative sign. મેં કહ્યું કે chemical reaction માં આપણે we are mentioning it with the negative sign. So nitrogen માટે 26.0 અને minus 13.4 electron volt, અને ઓક્સિજન માટે minus 32 to minus 35.3, and here it is minus 14.8 to minus 17.8. આ પણ ડિફરન્સ આપણે જોઈ લઈએ કે શા માટે એવું છે. કાર્બન, નાઇટ્રોજન, ઓક્સિજન માટે જોઈ લઈએ. કાર્બનમાં એટોમિક નંબર 6, so number of protons also will be 6. અને અહીંયા માનો કે 2s ના ઇલેક્ટ્રોન ની વાત કરીએ તો અહીંયા ઇલેક્ટ્રોન છે. So one type of the forces of attraction will be there. અહીંયા value છે 21.4. This is for the carbon atom. હવે નાઇટ્રોજન એટમ ની વાત કરીએ તો એટોમિક નંબર 7 છે. So અહીંયા એક પ્રોટોન ની સંખ્યા વધારે છે. One more proton is there. So here ખાલી 2s ની જ વાત કરીએ છે. So here forces of attraction will be comparatively more. One more proton is there. So forces of attraction will be more, and here it is 26.0. So 21.4 and 26.0. શા માટે? કારણ કે એક પ્રોટોન વધારે છે. So forces of attraction will be more. So it will be requiring more amount of energy for the removal of this electron. Oxygen atom, atomic number 8. So here total number of the protons will be 8. So from the 2s orbital, if we want to remove the electron, it is minus 32 to minus 35.3. Forces of attraction has increased. એક વધારે પ્રોટોન છે, so forces of attraction will be more, therefore more amount of energy has to be provided for its. So this is VSIP, balanced state ionization potential. The potential that we need to apply for the removal of an electron from the balanced state. to convert it into a respective channel. So this is about VSIP. Now let us talk about the VSEPR theory, that is the last part. Any question regarding VSIP?
No, sir.
Okay. Valence shell electron pair repulsion theory, VSEPR. Initially, it was developed in 1940. It was developed by Sidgwick
And Powell.
and Powell. Further, it was developed by 1957 Gillespie and Nigel.
मम्मी जापिन कहाँ है? क्या बॉक्स में?
Please mute yourself. Sagar, dear, please mute yourself.
અહીંયા જ એક નાનું ડબ્બી છે જો ને પડેલી.
Okay. 1940, it was developed by Sidgwick and Powell. Further, it was modified in 1957 by Gillespie and Nyholm. And many more theories, Walsh diagram, eddy walls, then Henry bend, they developed it further. So that let us see what is this VSEPR theory. Basically, prediction of the shape can be there depending on the number of the electron pairs present in the outermost shell, in the valence shell. Say for example, number of electron pairs present in the outermost shell. If it is 2, then probable hybridization, it will be sp hybridization with the shape of the molecule. It will be linear with the bond angle 180 degree. So this will be the situation with 180 degree. If the number of the electron pairs in the outer shell is equal to 3, then it can be sp2 hybridization with planar triangle. No. Planar triangle with bond angle 120 degree. Like BF3 molecule. This is like CO2 molecule. If it is 4, then sp3 hybridization. Hybridization can be found out, the shape of the molecule can be found out if we know the number of the electron pairs present in the outermost shell. Bond angle can be determined and so on. It will be tetrahedral with 109 degree 28 minute. Say for example CCl4 or CH4 and so on. If 5, it is DsP2 hybridization with TBP trigonal bipyramidal with this 120 degree, upper one, lower one, this will be forming 90 degree. Say for example PCl5 and last one 6, E2sp3, that is octahedral. All the bond angles are of 90 degrees, say for example SF6. So depending upon the number of the electron pairs present in the outermost shell, we can find out the hybridization, we can find out the shape of the molecule, we can find out the bond angle present in the molecule. This is VSEPR theory. Moreover, further, the Sidgwick and Powell, they found out that the electrons that are present in the outermost orbital, they can be either present in the bond pair or they can be present in the lone pair. Say for example NH3 molecule. So nitrogen atomic number 7, helium 4, 1s2, 2s2, 2p, 2 plus 2, 4 plus 3, 7. So in this case, what will happen? This is now hybrid orbitals, sp3 hybrid orbitals, in which one will be completely occupied and in the remaining 3, 1, 1, 1 electrons will be present. Now it is the sp3 hybrid orbitals, right? So one is having lone pair on the nitrogen atom. So this is said to be lone pair and this is said to be bond pair that is capable of forming the bond, that has formed the bond. So this is said to be bond pair, this is said to be lone pair. Now if we talk about the bond pair, 2 electrons are there. Now here the nucleus is there. Here also the nucleus is there. On both the sides protons are there. So these electrons will be pulled in both the directions. So therefore the size of this particular bond pair will be comparatively small because on both the sides the protons are there. So both the electrons will be pulled on both the sides because on both the sides the nucleus is there and both the sides the protons are there. So it is pulled in both the sides, therefore its size will be comparatively smaller. Whereas if we talk about the lone pair, on this side, on one side proton is there, nucleus is there, proton is there, but on the other side, nucleus is not there. So on this side, the free space is available. So its size will be comparatively more because on the other side, not a single proton is present. Nucleus is not present on the opposite side. Therefore, free space is available and therefore the size will be comparatively more compared to the bond pair. Therefore, lone pair occupies more space, bond pair occupies less space. And therefore, this is the reason why if we talk about the CH4, in this case, the bond angle is 109 degree, 28 minutes. Why? Bond pair, bond pair, bond pair, bond pair. All are bond pair. Now, on this nitrogen, NH3, now in this case, this is comparatively having the larger space. So what it will do, it will pull all the 3 bonds, squeezing there. So this bond angle decreases from a regular 109 degree 28 minute to 107 degree 48 minute. ये जाड़िया क्या करेगा, ये तीनों को पुल करेगा. नाउ in the first example all are bond pairs, but in this case one lone pair is there. It occupies more space, so this is comparatively zodiac. So it will pull all the bonds, it will squeeze them. So from regular 109 degree 28 minute to it will come to 107 degree 48. What will happen with the oxygen? Oxygen 8, helium 4, 2s2, then 2p4. So here what will do? What will be done? 1, 2, 3, 4, 5, and total 6 electrons are already there, right? So 2 from the 2 hydrogen atoms. So it is having 2 lone pairs. एक जाड़िया और दूसरा जाड़िया. They are occupying more space. So further squeezing will be there on both the sides. So this bond angle further decreases to 104 degree 27 minute. So this is the outcome of the VSEPR theory. VSEPR theory easily explains the change in the bond angle from the regular tetrahedral to one lone pair and to 2 lone pairs. Now the shape also can be predicted from the regular one. How it can be done? Let us take one or two examples. Let us understand the shape of the BF3 molecule and BF4 minus ion. Let us understand about BF3. The hybridization and everything can be understood. Boron atomic number 5, helium 4, 2s2, 2p1. So this is about the ground state and excited state. Helium 4, 2s1, 2p2. So total 3 electrons are there. So 3 electrons from the 3 fluorine atom. This is sp2 hybridization. So if the 3 pairs are there in the valence in the outer shell, means it should have the sp2 hybridization with the planar triangle shape with the bond angle 120 degree each. Let us try to understand the shape of the BF4 minus ion. BF4 minus. So boron, I'm directly writing the let us write down ground state helium 4, 2s2, 2p1, ground state, excited state, helium 4, 2s1, 2p2, and boron minus helium 4, 2s1, 2p3. So what will be? One, two, three. Total 4 electrons are present. This is 2s, this is 2px, 2py, 2pz. Ultimately, the mixing up of all the 4 orbitals occurs and they form the regular tetrahedral structure. So 4 fluorine atom will come with 1 electron, 1, 2, 3, 4. So this is sp3 hybridization. 4, 1, 2, 3, 4 pairs are there. So it should be having sp3 hybridization with the tetrahedral shape. So BF4 minus is having tetrahedral shape. Similarly, we can also have the prediction of the various chlorophosphorus. Let us begin with PCl3 regular shape. So phosphorus atomic number 15. It is neon core 3s2. This is 1s2, 2s2, 2p6. 1s2, 2s2, 2p6. Total 10 number of the atoms are there. So total is 15. 10 plus 5, 3p3. So total 5 electrons are present in the valence state. This is about the ground state, excited state, neon core, 3s1, 3p4. So here also total 5 electrons are present. 1, 2, 3, 4, 5. So one lone pair is there. Now 3 chlorine atoms, they will come with 1 electron, right? And total 4 pairs are there. So it should be having the tetrahedral shape with 1 lone pair. So here also squeezing of the bond angle will be there. So PCl3 is regular tetrahedral shape. Now next one is PCl4 plus. Let us try to understand this, the shape of this one. Phosphorus 15, neon core 3s2, 3p3. This is about the ground state, excited state, neon core 3s1, 3p4, excited state, and phosphorus plus will be neon core 3s1, 3p3, right? So total 4 electrons are present in the outer shell. Moreover, 4, this is about phosphorus plus. 4 chlorine atoms, they will come with 1 electron. So total 4 pairs are present. So shape should be regular tetrahedral. Cl, 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 Cl. So with a regular 109 degree 28 minute. So PCl4 is having tetrahedral shape. Of course, this can be have with Cl minus. Like anyway, this is not required. Let us understand about PCl5. So phosphorus 15, neon core 3s2, 3p3, excited state, neon core 3s1, 3p3, 3d1. This also can be possible if it all depends upon how many total number of the ligands they are coming closer to the centrally situated atom. Now 5, so 3s, 3p and 3ps, 3px, dy, dz, d orbital. કઈ d orbital છે એ આપણે જોયું હતું કે TBP માં કઈ d orbital involved છે. So 111 electrons and 5 chlorine atoms, they are coming with 111 electron. So total 5 pairs are present. Therefore, the shape should be trigonal bipyramidal with 120-degree planar one and upper and lower with the 90-degree bond angle. Last molecule PCl6 minus and so phosphorus 15, neon for 3s2, 3p3, excited state neon for 3s1, 3d1. Phosphorus minus will be neon core 3s1, 3p3, 3d2. So now 3s, 3px, 3s, 3px, 3py, 3pz, px square minus y square dz square. So total 1 plus 3, 4 plus 2, 6 electrons are present. 1, 2, 3, 4, 5, 6. So 6 chlorine atoms, they are coming with 1 electron. So total 6 electron pairs are there. Therefore, shape should be regular octahedral. So this is the explanation of some of the molecules. Moreover, the एक मिनट प्लीज. हाँ बोलो साહેબ. જય હો. પેપર એ લોકો મોકલશે અને આપણે અડધો કલાક પહેલા પેલું પેપર મોકલશે અને થોડાક વખત પહેલા કી પેલું અરે પેલો કોડ મોકલશે, પ્રિન્ટિંગ લઈ અને છોકરાઓને પેપર આપી દેવાનું. ના 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 એ તો ક્યાંથી નીકળતું. અરે એ તો હોતી નથી. આ બધું પેલું જવા દો. આપણે પેલા સાહેબ આયા હતા એને એમણે બધું બાયફર્કેશન નથી લેતા. મને ખબર છે. હા ખરી વાત છે. હાસો એટલે હવે પેલા લોકો જેટલું લિસ્ટ મોકલ્યું છે એટલા લોકો પરીક્ષા આપી દીધેલી છે. એટલા લોકોની નથી લેવાની, બાકી નાની બધાની લેવાની. તમારામાં તો બધાની જ લેવાની છે, કોઈ સવાલ જ નથી. હા એટલે એ એક્સટર્નલ માં કન્સિડર કરશે. ઇન્ટરનલ તો લેતા જ નથી ને આપણે સાહેબ. એક્સટર્નલ પરીક્ષા જ લીધેલી છે. ના ના એટલે એ બધો ઓર્ડર રિવર્સ થઈ ગયો છે. તમે ઓરિજિનલ જોશો ને તો છેલ્લો જે મેલ છે જોઈ લઉં હું. ચલો હા હા બરોબર. ખરી વાત છે. બરોબર છે. જોઈ કોલેજમાં છું. ચોક્કસ કાલથી ચાલુ થાય છે પરીક્ષા. લાઈફ સાયન્સ હા એટલે એજી આવે છે એજી કહી દઉં ચોક્કસ ચોક્કસ ઓકે so the So lastly, concluding, we have the lone pair, we have the bond pair. So as we have seen, between the two lone pairs, the maximum mutual repulsion will be there because both occupying more space. So lone pair will be having maximum mutual repulsion. One bond pair is there. So if one bond pair is there, so in that particular situation, this is slim one, this is fatty one. So comparatively here both fatty, so maximum mutual repulsion, only one fatty, so repulsion intensity will be comparatively less. And with the bond pair, the normal regular shape will be there. So minimum mutual repulsion will be there, right? Triple bond will be having maximum mutual repulsion, double bond will be having comparatively less repulsion, and single bond will be having least amount of the repulsion because the number of the outermost electrons will be comparatively less. Here 2 electrons are there, here 2 pair is there, here 3 pair is there, right? 3 pair, 2 pair and 1 pair. So here maximum mutual repulsion intensity decreases. It is a minimum with the single bond. It all also depends upon the electronegativity of the centrally situated atom and the ligands which are present. It also depends upon the electronegativity of the centrally situated atom as well as the ligands attached to it. So this is about something regarding the VSEPR theory. Any question, my dear friends?
No, sir.
So let us conclude our part. If any question is there, you can PM me. I will definitely reply. બાકીના સેલ્ફ કન્સિસ્ટન્ટ ફિલ્ડ મેથડ અને મેં કહ્યું એ પ્રમાણે પીપીપી એપ્રોક્સિમેશન એ કમ્પેરેટિવલી લેન્ધી છે. સો આપણે સવાલના જવાબો આપણે 2 કલાકની અંદર લખી શકાય એવા નથી. સો લેટ અસ ઓમિટ 3 કલાકની રેગ્યુલર એક્ઝામ થાય ડેફિનેટલી. અથવા કોઈને પર્સનલી રસ હોય ગેટ એક્ઝામ કે બીજી કોઈ એક્ઝામ આપવી હોય અને કંઈ રસ હોય તો યુ કેન પીએમ મી, આઈ વિલ એક્સપ્લેન ઇટ ટુ યુ. બાકી આપણે એમએસસી માટે આ વખતે જરૂરી નથી. ઓકે, સો વિશ યુ ઓલ ધ બેસ્ટ ફોર ધી એક્ઝામિનેશન. Not only the examination, now we are not meeting, and wishing you all the best for your future also. Okay, bye everyone.
Bye, sir. Thank you.
થેન્ક યુ સર. થેન્ક યુ સર. આપણે ક્વેશ્ચન એક વખત લખાવી દે તો મતલબ આ પેપરમાંથી કયા
મેં કયા હતા ફરી એક વખત લખી લો. એક તો HMO થિયરીમાંથી એક સવાલ હોઈ શકે. જનરલી તમે કોઈ પણ છેલ્લા વર્ષોના પેપર જોશો તો એમાંથી પેપર સ્ટાઇલ મળી રહેશે, પણ એક HMO માંથી એક સવાલ હોઈ શકે. પછી એક સવાલ બેન્ટ રૂલનો હોઈ શકે, એક સવાલ વોલ્સ ડાયાગ્રામમાંથી હોઈ શકે, અને એક સવાલ આ VSIP અથવા VSEPR થિયરીમાંથી હોય. બાકી 2 રહ્યા સેલ્ફ કન્સિસ્ટન્ટ ફિલ્ડ મેથડ અને પીપીપી એપ્રોક્સિમેશન. મેં કોઈ એ પ્રમાણે થોડા લેન્ધી છે, સો વી કેન ઓમિટ ધીસ ટાઈમ.
જી સર, થેન્ક યુ.
Okay, So all the best for the examination.
Thank you, sir.